Good day, everyone. I'm Karina May Sandra C. Salmon, and I'm going to discuss about macadam asphalt and surface treatment. First, let's discuss about macadam asphalt and its brief history. Macadam is a type of road construction pioneered by Scottish engineer John Loudon Macadam around 1820. John Loudon Macadam is a surveyor. He became a commissioner for paving in 1806 in England. And on 15th of January in 1816, he was elected Surveyor General of Roads for the Turnpike Trust and was responsible for the 149 miles of road. He propagated his ideas into two booklets called Remarks on the Present System of Road Making, which ran 9 editions between 1816 and 1827, and a practical essay on the scientific repair and preservation of public roads published in 1819. This type of road construction consists of single-sized crushed stone layers of which angular stones are placed in shallow lifts and compacted thoroughly. A binding layer of stone dust or crushed stone from the original material may form. It may also, after rolling, be covered with a binder to keep dust and stones together. Macadam's method was simpler yet more effective at protecting roadways. He discovered that massive foundations of rock upon rock were unnecessary and asserted that native soil alone would support the road and traffic upon it, as long as it was covered by a road crust that would protect the soil underneath from water and wear. Macadam's renown is due to his effective and its economical construction, which was a great improvement over the methods used by his generation. He emphasized that roads could be constructed for any kind of traffic. His legacy lies in his advocacy of effective road maintenance and management. He advocated a central road authority with trained professional officials who could be paid a salary that would keep them from corruption. These professionals could give their entire time to these duties and be held responsible for their actions. Macadam's road building technology was applied to roads by other engineers. One of these engineers was Richard Edgeworth, who filled the gaps between the surface stones with a mixture of stone, dust, and water, providing a smoother surface for the increased traffic using the roads. This basic method of construction is sometimes known as water-bound macadam. Although this method required a great deal of manual labor, it resulted in a strong and free-draining pavement. Roads constructed in this manner were described as macadamized. Another influence of macadam's method is a tar-bound macadam. With the advent of motor vehicles, dust became a serious problem on macadam roads. The area of low air pressure created under fast-moving vehicles sucked dust from the road surface, creating the dust clouds and a gradual unraveling of the road material. This problem was approached by spraying tar on the surface to create tar-bound macadam. Because of the historic use of macadam as a road surface, roads in some parts of the United States are often referred to as macadam, even though they might be made of asphalt or concrete. Now, in modern macadam construction, crushed stone or gravel is placed on the compacted base course and bound together with asphalt cement or hot tar. So, macadam's road cross-section was composed of a compacted subgrade of crushed granite or greenstone designed to support the load, covered by a surface of light stone to absorb wear and tear and shed water to the drainage ditches. Now, in modern macadam construction, crushed stone or gravel is placed on a compacted base course and bound together with asphalt cement or hot tar. And that's what it makes a macadam asphalt. And now let's proceed to surface treatment. Surface treatment is the application of an asphalt emulsion on either an existing asphalt road or a fresh, compacted granular surface immediately followed by the application of a cover aggregate. It is mainly constructed to perform certain important designated functions, such as to provide a wear-resistant surface and to increase the skid resistance. However, aside from such primary purposes, other less important benefits may also result from its construction. Thus, in the following listing, the more important functions of a surface treatment are given separately. First, to provide an abrasion-resistant surface. In the lower types of roads, where the soil is stabilized either by compaction or addition of cement, bituminous binder, or chemical compounds, the stabilized material does not have satisfactory resistance to the abrasive action of the tires. Second is to increase skid resistance. Bleeding bituminous surfaces and polished, worn-out concrete pavements often induce hazards to the movement of a vehicle because of the lack of skid resistance. Third is to improve light reflection characteristics. Dark-colored surfaces are often hazardous to the vehicle operator due to poor visibility and the lack of luminosity at night. Fourth is to provide lane demarcation. On high-type pavements where shoulders are often paved to increase their stability, a demarcation for traffic guidance is often needed between the shoulder sections and the traffic lanes. This can be done by constructing upon the shoulder either a rougher surface or a surface of a different color from the pavement. Next is the secondary purposes of a surface treatment. First, to seal the underlying surface. Entrance of air and water through the voids present in pavements, especially in the case of often textured pavements such as bituminous macadams, in one entrance of air and water through the voids present in pavements, especially in the case of open textured pavements such as bituminous macadams, is one of the main cases for road deterioration. Second is to enliven old pavements. Old, dry, and weathered pavements may often not show signs of substantial failure, yet will still require the aid of maintenance to enliven them. Third is to improve surface irregularities and appearance. Surface irregularities in a pavement resulting from poor construction, severe weather, or traffic conditions can be improved substantially by the construction of a new surface treatment. And lastly, to add structural strength. A major portion of the structural strength of a flexible pavement is provided by its thickness. This determines the amount of stress transferred to the subgrade. One type of surface treatment is fog seals. A fog seal is an application of a specially formulated asphalt emulsion, a thin liquid oil, to an existing asphalt pavement surface. A fog seal gets its name from its spray application, sometimes referred to as fogging. As asphalt pavement is subjected to traffic loads and ages, it oxidizes and cracks develop in the surface due to part of the pavement becoming more brittle. Another type of surface treatment is slurry seals. Slurry seal is the application of a mixture of water, asphalt emulsion, aggregate, and additives to an existing asphalt pavement surface. A slurry seal is similar to a fog seal except the slurry seal has aggregates as part of the mixture. Polymer is commonly added to the asphalt emulsion to provide better mixture properties. Next is microsurfacing. Microsurfacing is similar to slurry seal. It consists of an application of a mixture of water, asphalt emulsion, and aggregates, and also chemical additives to an existing asphalt concrete pavement surface. Polymer is also commonly added to the asphalt emulsion to provide better mixture properties. The major difference between slurry seal and microsurfacing is in how they break or harden. Microsurfacing is an application that hardens quicker than slurry seals and can be used when conditions would not allow slurry seal to successfully place. And lastly, chip seals. A chip seal is a two-step process which includes first an application of asphalt emulsion and then a layer of crushed rock to an existing asphalt pavement surface. A chip seal gets its name from the chips or small crushed rock placed on the surface. And that's all my report. Thank you for listening.